Question number 14. Question number 15 from 2014. The kinetic data for a single substrate enzyme is shown. The concentration of the inhibitor used in the reaction is equal to the Ki of the inhibitor. The Km value of an uninhibited reaction is 2 into 10 to the power minus 5 molar. In the presence of an inhibitor, the observed Km value is dash into 10 to the power 5 molar. So let's look at this graph. So here again we see here that the y-intercept is same. Therefore Vmax for both the uh, reactions is same, and this is only true in the case of competitive inhibitor, as I have explained. Here you can see in competitive inhibition the Vmax is the same, y-intercept is same, and in no other inhibition it is same. Not in uncompetitive as well as non-competitive, it is not the same. So we have to use the competitive inhibition equation. What is that? So in presence of a competitive inhibitor, we can say I. So V0 would change to what is the normal V0? We know that normal equation, it is denoted by V0 equal to Vmax into S, which is the substrate concentration, divided by the sum of substrate concentration plus K. This is the normal equation for a uninhibited reaction, that is in the absence of any inhibitor. This is the normal reaction. So, but in presence of an inhibitor, the Km will change. Okay, because Vmax is constant, this is not changing, Km is changing, and the changed value of Km, it is denoted by Km into 1 plus 1 by Ki. Okay, that is also known, this 1 plus 1 by Ki can also be written as alpha. So this alpha factor gets, we have to multiply Km into alpha to get the actual Km of an inhibited reaction. And Ki, which is the inhibition constant, it is denoted by Ki over here, it is denoted by E, so, multiplying concentration of enzyme, concentration of inhibitor divided by the concentration of the enzyme inhibitor complex. This is the free enzyme, free inhibitor, and this is the enzyme inhibitor complex. Then you can calculate V0, that is you replace this by alpha, and alpha can be denoted by this. This type of inhibition can be determined using the double reciprocal product. So what we have to find out here is the Km of an uninhibited reaction is given. In the presence of an inhibitor, the observed Km value we have to find out. That is Km in the presence of an inhibitor. Km into I. Km I. That is in the presence of inhibitor, that will be alpha into Km. Now Km is already given. Km is 2 into 10 to the power minus 5. We have to find out alpha. What is alpha? 1 plus, as you have seen, I, that is in inhibitor concentration, divided by Ki. So let's go back. 1 plus I by Ki into K. That will give you the Km in the presence of an inhibitor. So the concentration of the inhibitor used in the reaction is equal to the Ki. So if concentration of inhibitor and Ki is same, so both of these will cancel out. So value of would be 1 plus 1 into Km, that is 2 into Km, 2 into Km, and we have Km that is told in this question only, that is 2 into 10 to the power minus 5. So it will be, the answer will be 4 into 10 to the power minus 5 if you multiply it. Okay. 4 into 10 to the power minus 5 molar. And so they are asking, in the presence of inhibitor, the observed Km value will be dash into 10 to the power minus 5. So 10 to the power minus 5 molar is already given. So what you have to write is only 4. So the answer of this question will be 4. You have to write only 4.